Morning, everyone. I'm happy to see that people have already started to use our questions feature this morning, saying hi, asking what our lovely presenter on screen has in the cup. I'm pretty sure it's coffee, hopefully. So happy to have all of you here today. And I know we're actually, I think, starting 1 minute late, so I won't pause to wait for more people to join, because it looks like we've got pretty close to everyone that RSVP'd in the list already. I'm Jacqueline Garcia, our Education Manager at Synergex. And for those of you joining today, the webinar that we're about to present is Integrating Traditional Synergy Logic with Harmony Core Web Services. This is the 4th webinar we've done in this series, but if you haven't seen the previous ones, that's okay. You can get caught up later on YouTube. But this one will be recorded as well and posted to our YouTube channel. So if you want to share it with a colleague or friend afterwards, you definitely can. Another little housekeeping thing, we will open up to questions at the end. You're still welcome to send in questions as you go. I'm seeing lots of hi's come into the box right now. So hi, Alan. Hi, Christian. But if something needs to be addressed right away, I'll go ahead and jump in and address it. But otherwise, we'll save questions till the end. And I'll also allow you guys to unmute yourselves at the end to actually interact with us a little bit more. Let's see. So we've got our usual suspects back again to present. First, you see him on screen, our longtime member of our consulting staff and recent transition into a product management role. We've got Steve Ives, and also on the line we've got our Harmony Core technical lead and principal engineer here at Synergex, Jeff Green, that will help answer questions at the end. You might also see another staff member's name in the list. Liz Wilson is a brand new employee of Synergex, and she's going to be helping take over managing these webinars in the future. So you'll hear from her more in the future. So that's the team we got for you today. And I guess without further ado, Steve, you can go ahead and take it away.
Okay, thank you. Good morning, everybody. Next in the series of our Harmony Core webinars, today we're going to be talking about integrating traditional Synergy code specifically using a technology that Harmony Core includes called Traditional Bridge. Before we get into code, and there's going to be a lot of code today, let me just take a couple of minutes to explain to you what Traditional Bridge actually is. It's essentially a Harmony Core technology that allows you to incorporate traditional Synergy code, DBR code, subroutines and functions in ELBs into a Harmony Core solution. Think XF Server Plus, we're calling traditional Synergy stuff from .NET or from Java, but think XF Server Plus, but standards based and better. So the core functionality is calling traditional Synergy code from Harmony Core. That might be exposing entire endpoints from backed up by a traditional Synergy routine, or it might just be supporting code that in something that you're doing in the web service you need to interact with traditional Synergy, be it on the same machine or another machine. This also potentially is a way of doing XF Server Plus migration, but that's a whole different specific set of stuff where we do some code generation based on method catalogs and so on. That's not what we're going to be doing today. We'll talk about that another time probably. So today we're talking about manually writing code to incorporate code. We're not going to see a bunch of code generation today. There are two ways that Traditional Bridge can be leveraged. You can either have a local configuration where essentially you have traditional Synergy in a DBR or a DBS process running on the same system as Harmony Core on Windows, but without any TCP/IP component. If you were to use XF Server Plus, XF Netlink.net, for example, on the same Windows machine, you're still going through all of those network stacks and so on. With Harmony Core, you're not doing that. We're talking directly to a process. You can also do remote configurations. So in that scenario, Harmony Core establishes essentially an SSH tunnel to any remote system. So essentially, it behaves just like a user logging in, and it SSHs to the machine, it logs in, it basically runs an application and talks to that application. And we'll see a little bit about how that works as we go through. So the back end of Harmony Core is traditional Synergy. And the point is that could be on the local Windows machine, or it could be on a remote Windows, Unix, Linux, OpenVMS machine. It doesn't matter. It's simply a matter of configuration to tell the Harmony Core system where the back end traditional Synergy environment is. So this is your mechanism also for incorporating business logic on an OpenVMS system, for example. The protocol that's used to communicate between Harmony Core and the traditional Synergy environment is a standard protocol. It's a protocol called JSON RPC2. It's a simple JSON messaging format where a message includes information about the method to be called and any in or in-out parameter values, and the response coming back from the traditional Synergy environment is also a JSON message that includes the result of any in-out parameters or out or in-out parameters and the return value of the routine. So it's a very simple JSON messaging format based on, like I say, a protocol called JSON RPC2. The communication mechanism, as far as the traditional Synergy program, the DBR, is concerned, is just standard in, standard out, which makes it extremely simple. Essentially, it's the terminal channel. It receives messages on the terminal channel, just as if you were to type fast enough and enter the correct JSON, you can manually interact with this thing. So it just receives messages on the terminal channel, does whatever it needs to do, and responds by sending JSON out of the terminal channel. So it's a very simple mechanism. And it's easy to implement. You might think, oh, all this communication and all this JSON and so on to deal with, but Harmony Core library code does all of the hard work for you on both ends. So you're not dealing with low-level JSON or JSON RPC messages yourself. There is an API that you interact with to allow you to do that. Slight warning, this is going to be rapid fire. I am going to be dealing with an awful lot of code this morning. We're going to be working through a lot of code. There's no, like I said earlier, there's zero code generation in this session. This is all going to be manually configured stuff. But again, as I mentioned last time, everything you see here is backed up by a hands-on tutorial that is already published on the website, on the Harmony Core wiki on GitHub, where all of our documentation resides. And everything you see today, you can follow through yourself and do in a step-by-step tutorial. So there's a lot more information and explanation about more detail about exactly what's happening out there and available for you. So this is all about custom code. There's no code generation. And this is all, it's all about custom traditional Synergy code. And then we'll deal with writing custom .NET code and XF Server Plus migration and all of that kind of stuff in future webinars. We are picking up exactly where we left off last time. So this is the exact same solution that we built up 2 webinars ago. We built up an OData service that's exposing functionality about our customers and orders and vendors and so on. It's that exact same service. In the last webinar, we added custom authentication to that solution. So we do have to use Postman. We've got our JSON Web Tokens in play. Our Harmony Core traditional bridge endpoints that we're going to add today will also be protected by that exact same mechanism. So we do have to authenticate, get a JSON Web Token in order to talk to the service. In the spirit of open source and the inherent transparency that comes with that, I will admit that we have fixed a few bugs in the last couple of weeks, and we have done a couple of Harmony Core releases in the last couple of weeks. So the version of Harmony Core that I'm using is not the same as it was a couple of weeks ago. And the point of that is that it's now, for you guys even, it's super easy to upgrade existing solutions. We do have now a command line tool that will upgrade your solution to the latest version and provide you with all the latest templates and everything, and it's super easy to do. And again, there is a specific page in the documentation in the wiki that tells you exactly how to do that. So without further ado, let's get back to our code. here's our solution. The first thing we're going to do is we're going to add a brand new project to the solution. So I'm going to right click and add and say new project. And what I'm going to be doing is adding a traditional application DBR project. So everything else in here is .NET. Now we're going to be dealing with traditional Synergy. And like I said, it's just a DBR that gets run by Harmony Core. And we're going to name that project Traditional Bridge. Okay, so let's create that project. I do apologize that I'm going to be glancing over this way quite a bit in this session because I have a document of instructions right in front of me, and then I'm working over to my right over there. Okay, so the first thing I'm going to do is actually change the name of the DBR that's getting produced by this thing. As you probably know, when you create a DBR project in Visual Studio, you get this sample generic program.dbl. So the first thing I'm going to do is I'm going to rename that to Traditional Bridge Host, which is what I want the name of the DBR to be produced by this project to be. I don't really have to do this, but because I'm kind of anal about this sort of stuff, I'm actually going to explicitly name the program in the source code. And I'm going to do a third thing, which is I'm going to go to Project Properties, and I'm going to change the output name, which will actually change the name of the DBR that's produced by this project as well. So we've changed the name of the output to Traditional Bridge Host.dbr, essentially. The next thing I'm going to do is I'm going to bring in a bunch of traditional bridge library code that Harmony Core provides. As I already mentioned, Harmony Core provides most of the code that does all of the heavy lifting, or all of the code that does all of the heavy lifting. And that on the traditional Synergy side includes a whole bunch of of classes basically that do all of that work. So the first thing I'm going to do is I'm going to add a folder to the project, and I'm going to call it Bridge. So this is going to be our traditional bridge library code. And then I'm going to cheat. The way I'm going to get this code, I could go off to GitHub and grab the latest version of the code and so on. But I want to do this in a way that I ensure that I keep the version of the code that I'm grabbing in sync with the version of Harmony Core that I'm using. So I'm actually going to use our project upgrade tool to bring this code down for me, because it does keep all of the templates that are being used up to date, as well as the Harmony Core versions, and it also keeps the traditional bridge code in sync with the version of Harmony Core that you're using. So to do that, I'm going to cheat a little bit, and I'm going to create a routine called, where are we, new item. I'm going to create a new item, which is a class, and I'm going to call that class routinedispatcher.dbl. And I'm doing this because I happen to know that that's the name of one of the routines, and I happen to know that the project upgrade tool will detect that and figure out, oh, this is where I need to put the bridge code. So I'm going to do, what I'm going to do now is save that. I'm going to open a command prompt because the tool is a command line tool. I'm going to go up to the solution directory. I'm actually going to close down the Visual Studio solution because I'm about to bring in, why did I do that? I did not want to hit don't save at that point. Just bear with me a second. Yeah, okay, I didn't save the solution. So now I need to add existing project. I don't know why I did that. Traditional bridge. Let's add the traditional bridge project back into the solution, which is the thing that I failed. Oh, and it lost its folder. Okay. Add existing item, bridge, routine dispatcher, save. Okay, this time we'll save it. So we're going to save. I'm going to close down the solution. Go back to our command prompt, and now what I can do is essentially run the command line tool to basically, I'm pretending I'm upgrading the project. That is not copying either, bear with me. Okay, so I'm using a command which is Harmony Core upgrade latest. And that is going to basically, it's asking me to confirm that this is going to change source code and update my projects. That's fine. and you can see it's updating traditional bridge files in my bridge folder. It found that empty source file there and provided me with a copy of it. So now, no, I didn't want to open that. It's not going well this morning, is it? Okay. Oh, it figured it out. Okay. Clever Visual Studio. So now, if we look at the routine dispatcher, we'll find that we've actually got source code in that file. Okay. And in fact, we'll find that if I add existing item and go to the bridge folder, we've got a whole bunch of code that was provided by the project upgrade tool. So this is the traditional bridge library code that does all of the JSON parsing and JSON RPC requests and response and all of the basically the scaffolding that makes this whole thing work on the traditional Synergy side. So we now have all of that code in place. Okay. The next thing we're going to do is we're going to bring in the actual Synergy routines that we're trying to expose. So these might be existing library routines that you've got. And again, at this point, you might actually go off and reference an ELB that's got your existing business logic in it. Or if you're writing specific routines that you want to expose new routines, then you might do what I'm going to do here, and I'm going to just incorporate them straight into my project. So I'm going to create a folder, and I'm going to call this folder methods. Okay, so these are anything in the methods folder is basically going to be the source code that I'm actually exposing and calling as functions from the Harmony Core environment. And what I'm going to do is I'm going to drag in 3 existing source files. These files exist in our sample environment. If you create a project from the Harmony demo solution, then this whole thing will already be in play, by the way. So you will have exactly what you're seeing me build up step by step. So I'm dragging in 3 existing source files. You can see those source files are called get environment. They're all very, very simple. All that get environment does is it basically is a function that returns an alpha value, and it returns the Synergy version string. Synergy DE version 11.1.1c, whatever that string is, we'll see in a little while. The second routine is a little bit more complex because it has an inbound alpha parameter and is a function that returns an alpha. That parameter is a logical name. So we're literally returning the value of a server-side logical name. We're doing an xcall getlog, and we're returning the translation of the logical name if it exists, or we're returning a blank string if it does not exist. And the third routine, you'll never guess what this one does based on its name, add 2 numbers. So add 2 numbers, as its name suggests. This time it's a subroutine, just to show you an example of calling a subroutine instead of a function. And so there's no return value, but now we have 3 parameters, which are 2 numbers which are inbound, and we return the result. We add the 2 numbers together and update into the result parameter and return the result. So it literally adds 2 numbers together and returns the result. So these are the 3 routines. These are our fake business logic routines, essentially, that we want to expose through the web service. So let's save everything. Let's just make sure that everything is building correctly. So we'll do a build, and we'll make sure we get a build once succeeded. So our library code, so we now have our traditional library code, our traditional bridge code, and we have the methods that we're exposing through the service. Okay, what's next? The next step is to create something called a dispatcher. So for each method that you're exposing on the traditional Synergy code, you have to have a dispatcher. And essentially what the dispatcher is it is code that deals with the inbound request and looks at any values of any inbound parameters, for example, and extracts them from the message and puts them into appropriate variables. It then calls the underlying routine, dealing with those variables, passing those variables, also passing any variables to receive any out parameters, and then it deals with placing any outbound function return value and or parameters into the JSON RPC response. So that's the 3 things that these dispatchers do. We have to have one for each of the methods that we're going to write. So let's close all of our source code. And what we're going to do now is, and again, you don't have to organize things into folders like this. I just find it easier to keep things organized. So we'll call it dispatchers. And what I'm going to do is I'm going to add 3 new classes here. So we'll say add class, and we'll call the first one get environment dispatcher. Okay, I'm just going to leave it as a default class right now. We'll add a second one, which we will call get logical name dispatcher, and then we'll add a third one, which is going to be called, I bet you can't guess, add to numbers dispatcher. Okay, so there's our 3 dispatcher classes. Now what I'm going to do again is I'm going to cheat a little bit, and I'm going to copy in some scaffolding code into each of those, and then we'll walk through and modify the code as necessary and explain how this works. So there's add 2 numbers. I'm going to select all and replace. Where we get logical name, I'm going to select all and replace, and get environment, I'm going to select all and replace. Okay, so this is just the basic scaffolding for how a dispatcher works. You'll notice that I've got this keyword routine here and there. So the first thing I need to do is this is going to be our get environment dispatcher. So the first thing I'm going to do is replace the word routine with get environment. And that will just change the name of the comments, the name of the class, and so on. Okay, so that's the first thing we've done. So we can see here that this is a class that extends something called routine stub. So that's a class that's provided by the traditional bridge code, and provides all of the low-level functionality that actually does the bulk of the work. Within that class, you'll notice we're overriding a method called dispatch internal, and this is the method that's called when we're trying to dispatch to a traditional Synergy routine. And this routine receives a whole bunch of information. Essentially, the name is the name of the routine to be called. So you could set up a dispatcher that looks at this parameter and does different things based on which routine it is. I'm taking a different approach and creating a dispatcher for each of the routines. The call frame essentially is the JSON represents the JSON request. It's a JSON element. That means in version 11 is something called a JSON element class. Okay, you really don't need to know too much about the internals here. You'll see how it's used. The serializer is the serializer that we're using to build up the outbound response, so we can interact with that to build our response and add information to the response. And the dispatcher is basically representing the dispatcher that's going to be used to call this particular routine. You'll notice we've got some data in here. We've got some code already that is extracting arguments. So it's using call frame get property params. That gives us information about the arguments to the routine, if there are any. And you'll notice we've got 3 comments saying add code to deserialize inbound parameters, call the underlying routine, and serialize any outbound return value and or parameters here. So we have to basically plug in code for these 3 things. Deal with any inbound parameters, call the routine, and then serialize the output, or essentially return any information that we need to. Now, in this case, the underlying routine that we're calling, if we remind ourselves quickly and look at get environment, it doesn't have any inbound parameters, but it does have a return value, which is defined as alpha. So what we will need to do, and again, there are various ways that you could do this, but I'm going to take a fairly simple approach, and I'm going to define a variable called return value, which I'm going to use a string to represent the return value, so I don't have to deal with fixed lengths here at this point. And the traditional Synergy will marshal strings into alphas for me just fine. I don't have any inbound parameters to deal with, so in this case, we can just ignore this section. And then all we need to do is simply call the underlying routine that we're trying to access and capture the return value into the variable that we've just defined. And then we need a little bit of magic code to place that return value into the outbound JSON RPC message. And that's what this code does. So serializer.argument data, we're providing to the serializer argument data for argument number 0, which is the return value. Argument number 1 is the first argument, 2 is the second argument, and so on. And we're telling it, there's the value, and it's an alpha field, okay, and a bit more information, the length. This would be the precision if it's implied decimal, and true says it could contain binary data. Okay, it won't in this case, but it could. So it will, the protocol will allow that. So that's it. That's all we have to do to expose that routine. Okay. Then we basically need to do the same thing for the 2 subsequent routines. So we'll fly through this fairly quickly because it's fairly simple. Actually, the first thing I need to do is, again, I need to replace the routine. So I'm using Control-H, which is replace all. And we're replacing the label routine. This time we're going to replace it with get logical name. So our class is now called, oh, I guess I did there we go, get all. So our class is now get logical name dispatcher. And then basically we have to do the same thing. This time we do have an inbound parameter and we also have a return value. So I'm going to declare 2 variables, okay? We're going to be doing an X called getLog, and you can't pass a string to a getLog, so I am actually using an A256 that we can use for our X called getLog call. Or under the hood, it's a getLog call. Then we're going to deal with grabbing the inbound parameters. So this is the first time we've seen this code. So what this code is going to do is we refer to the dispatcher, which is our current request essentially, and we ask it to get text. There are various other overloads for get decimal, get implied, get, there's various methods that are used, discussed in the documentation for based on the type of parameter it is, and then arguments 1 is the first inbound parameter. Arguments here we got from the params message in the JSON RPC message. So that's how we extract values. We use dispatcher.get, an appropriate method based on the data type, and tell it which argument we want to extract. So we've got our inbound data now. Our logical name is now sitting in that A256. And now what we need to do is again call the underlying routine. So again, we're going to do a get. We're going to call it, pass the logical name, grab the return value, and again, in exactly the same way as we did in the previous example, we simply build up or we add the information about argument data 0. Again, if you remember what the routine looks like, get logical name is a function with an inbound parameter. Okay, so we grab the inbound parameter, call a routine, and then return the value. So that's what we're doing here. Argument 0 represents the return value, and again, it's an alpha field of a certain length. Okay. So this is basically the task. You write the routine that you want to expose, and then you write a dispatcher that deals with inbound parameters, call the routine, serialize the parameters. Okay. By the way, if you're doing XF Server Plus migration, we generate all this stuff for you. Okay, so we read the method catalog and we generate everything for exposing that routine on both the traditional Synergy side and the .NET side. So you only have to do this if you're handcrafting, really custom code for traditional bridge. So that's our second one. We have a third one in play, of course. So let's now very quickly deal with the third one. This one is going to be called, let's replace routine with add 2 numbers and replace all. And let's do basically the exact same thing. Now we have 2 inbound parameters and 1 return parameter. Again, the routine we're exposing is this one, so it's a subroutine now, no return value. but we have 3 parameters, 2 inbound, 1 outbound. They're all defined as numeric. Okay, so decimal in traditional Synergy would be an appropriate data type. It's an implied decimal of the maximum size. So that will work. That's a D 28.10 or whatever it's defined as. I forget now. So there's our 3 arguments, arg1, arg2, arg3. Maybe I could be a little bit more inventive with the names, but that'll do for the time being. And again, let's go and grab our code that deals with the 2 inbound parameters. So now we're grabbing arg1, and you can see here, based on the type, dispatcher.getImplied argument 1 and argument 2. So that pulls the inbound parameters from the JSON RPC message. Again, we need to call the underlying routine, which is what we're going to do with this X call, simply arg1, arg2, arg3. And again, the 3rd parameter is an outbound parameter. So slightly different this time. Previously, we'd used this for the return value, argument 0. Now we're specifically saying argument 3, the return value is arg3, and it's a field data type implied decimal of 28.10, which is essentially what decimal translates to in traditional Synergy. Okay, and false, it won't contain binary data. Okay, so there's our 3 dispatchers in place. That's the hard work. Okay, we're on the downhill section at this point on the traditional Synergy side. We're done with most of the work. What we do need to do is we need to now create an overall method dispatcher. So we create a dispatcher for each of our routines. And then what we do is we create what I tend to refer to as a master dispatcher. And I'm calling it method dispatcher. As you can see, I just dragged one in. And again, here's the template for the code. So it's a class that extends, again, a Harmony call routine. So if you look in Bridge, you'll find, actually you won't because it's buried in, oh, there it is, routine dispatcher. So we're extending that routine dispatcher class, and we're providing a constructor. And all we have to do in here is declare all of our individual dispatchers. So this is where we're enabling routines, and we're telling the traditional Bridge environment about the dispatchers we have, and therefore about the routines that we're actually exposing. So literally what we need to do is say dispatch subs. Dispatch subs is a member of the class that we inherited from, that we extended. So dispatch subs.add, add 2 numbers, and we create an instance of the dispatcher for that method. So we're saying there is a routine called add 2 numbers, and here's an instance of the dispatcher class that knows how to deal with its parameters and knows how to call it, and will return the return information into the output stream. That's it. We simply plug in our dispatchers like that. So we have methods that we're exposing, we have dispatchers for each method, and we have an overall method dispatcher that plugs in and tells Harmony Core Traditional Bridge about about our environment. Okay. The only thing that remains on the traditional Synergy side is to create the actual hosting program itself. We've already got this placeholder traditional Bridge host, and the hosting program itself is actually remarkably simple. So what I'm going to do is just grab a little bit of code here that basically imports, I've lost my mouse now, there it is, that imports some namespaces that are going to be used, okay, and then I'm going to add a record to the data division, which simply contains some variables that are going to be used. Again, I'm aware that I'm going very quickly. Again, the tutorial on the website walks you through this stuff. I just want you guys to have an overview of how this works. And it's actually remarkably simple, as you'll see in a moment. So terminal channel, a length variable, a temporary alpha, a logging level, a log file name, and a dispatcher, which is going to be an instance of the method dispatcher that we just created. Okay, so that's what those variables represent. Very simple stuff. Then what I'm going to do is I want to have some error handling in here. So I'm going to use a try catch block. I just use the try catch snippet there to insert a try catch block. And what I'm going to do is add some code in here, and within the try, and this code, basically every method dispatcher will be the same. So once you've seen this, you can just cut and paste this into any scenario. the code is always pretty much the same. What we're doing is, first of all, we're communicating on standard in, standard out, which is the terminal channel. So we've got an xcall flags, which is configuring our environment, and we open the terminal channel on TT channel. So that's obviously important. That's how we're going to communicate with the outside world. So that's the first thing we do, open the terminal. The next thing we're going to do, I'm going to drop in a block of code, and all this code is doing is essentially determining what logging level we're going to use. So it looks at a logical name called harmony log level. Don't know why that doesn't have, let's put it on there anyway. Xcall get log harmony log level into temp A and length. And if the harmony log level is used, then we will use it as our logging level. Otherwise, we will default to a level of 2. Simply says how verbose is the logging. Level 2 is kind of normal, fairly minimal logging. Level 6 is the maximum you get the world kind of logging for debugging. So that determines our log level. Oh, I missed a bit. And there's also should be a bit of code here that it sets the name of the log file. So we're going to call it bridge jbno. That's our process ID.log. And we're going to create an instance of a class. Logger.instance is new logger. Again, in the bridge code, you'll find that logger is a class that's provided in the bridge code. We pass it the log file name, the logging level, and I can't remember what that one's for. Yeah, I'm not sure what false is for there. I honestly can't remember. And then finally, all we need to do is create an instance of our dispatcher and set it going to do its job. So very simply, we create a new instance of method dispatcher. That's this guy that we just wrote. Okay, the guy that tells Harmony Core traditional bridge about what's out there. So we create a new instance of it. We send out, this is really important, we send on the terminal channel a message that says ready, carriage return line feed. Traditional bridge on the .NET side, when it spins up one of these processes to deal with requests, waits and looks for that ready message to say, oh, the thing's up and running, we can start using it. Okay, so it's important that we issue that ready message. And then we simply say dispatcher.dispatch, and we pass it the terminal channel. And at this point, the traditional bridge code steps in and starts listening for requests, calling methods via the dispatchers and so on. Everything just happens under the hood. It's magic. All we need to do is deal with any exceptions that come back. So if there are any fatal errors that come back, I'm going to drop a little bit of code into the try catch block that simply grabs the, if we have a logger, it logs dispatcher exited with exception and records the value of the exception that was generated. And beyond that, I'm just going to add a little bit of cleanup code after the try catch, which basically terminates or closes the log file on exit and stops the application. Okay, that's it. Okay, and pretty much every dispatcher will basically look the same. So now you've seen it, you can use this in basically any scenario. The custom stuff is what dispatchers do we declare and what does each of those dispatchers do. Okay, so our traditional Synergy side of this scenario is almost complete. It's complete from a code standard point of view, but there's one final thing we have to do, and that is we could tell traditional bridge, just go and run this DBR. But the problem on Windows, and this is a Windows specific thing, is that on Windows by default, there's no default Synergy environment when you log into Windows. You generally have to call dblvars 32 or dblvars 64 to establish a Synergy environment. And it's very likely that you might want to set up logical names or environment variables for your application, for your data file locations, or establishing your application environment. On all the other platforms, on Linux, Unix, OpenVMS, you can use login scripts like login.com or bashrc or whatever it is, .profile, depending on what shell you're using. You could use those scripts to set up the environment. But on Windows, that doesn't happen. So what we tend to do is we tend to launch traditional bridge via a batch file. So I'm going to drag in a batch file. I'm going to put it right into the traditional bridge project. And you'll see all this batch file does is it calls Synergy dblvars 64.bat. Oh, I just remembered I forgot to do a step earlier. By default, in Visual Studio, things build 32-bit. So I'm actually going to make my code. It doesn't matter. I could use 32-bit if I wanted, but my parts of things, some things in other places are set up to use 64-bit. So we're going to go into the configuration manager, and I'm just going to change my traditional bridge to build x64 and tell it to build automatically. And then we'll do that in release mode as well. We'll go to 64-bit and build automatically. And we're going to leave ourselves in debug mode. So now we're building 64-bit. Let's just, actually, there's one other thing I want to change. So we brought in our batch file. It runs 64-bit Synergy, and then it literally just runs traditional bridge host. Notice here there's an alternate command that runs with DBR and starts things in remote debug. So if you want to be able to run this, spin this thing up and wait for 60 seconds and attach a debugger from Visual Studio, then you would comment out this command and remove that command. And now you can do end-to-end remote debugging of the traditional Synergy stuff, even if it's on a VMS system or a Unix system or whatever. So that's for debugging. Okay, so what we are going to do is one final change. And I am very aware of the time, and we are probably going to go a little bit long on this, so I do apologize for that, but we're going to complete. I'm going to set one property, which is copy to output directory, and I'm going to set that to copy always. All that will do is no matter where Visual Studio places the DBR file, it will also place the batch file alongside it. And in a traditional Synergy, well, the way that this environment is configured in our Harmony Core solutions is that if we go to the directory that we're working in, which is here, we've got this environment, we've got basically a setting in our common properties, which says XCDIR is solution to TB-XE, traditional bridge XE configuration, debug or release. So that's where we're actually building the source code to. And you can see here's our solution directory, here's TB-XE, debug, traditional bridge host, there's the DBR that we're building. And if we build this project again, we should see it is not going to, it is just not wanting to talk to me today. Copy to output directory, copy always. Okay. Let's try this one more time. If it refuses to do it it's still refusing to do it. So I'm going to figure out that later. For the time being, I'm going to cheat. I'm going to take a copy of that and I'm going to place it into the directory that it needs to be in, and then figure out why Visual Studio is not willing to do its stuff at a later date. Okay, so there's our environment. I apologize about that, but we will figure out what's going on there. So we're done on the traditional Synergy side. What we need to do now is plug this stuff into our .NET side. And that's going to involve basically 3 steps, okay? The first thing is we're going to be working primarily in our controllers project, and we're going to add 2 things to this. If you remember, the Harmony Core environment uses a dependency injection environment where services that are useful pieces of code to controllers are created as what are called service classes or service objects, and then a controller can request those things through dependency injection when it needs to. So we're going to create a service which knows how to call our underlying traditional Synergy code, and then we're going to create a controller that knows how to, that exposes the thing. So what we're going to do, I'm going to bring in some template code. So I'm going to bring in a file called traditional bridge service.dbl. And what this is extending a class called dynamic call provider. You can probably guess from its name that this code knows how to call remote routines through traditional bridge through JSON RPC. So this service has a bunch of functionality to do that. We have a constructor already provided that simply receives our connection. That represents our connection to the back-end traditional Synergy environment, and it simply passes that connection on into the parent class so that it can use that connection to make calls. And then essentially what we need to do is we need to add the code that knows how to call each of our methods. So I'm going to do this fairly quickly. There's a routine that, as you can see, we're doing every one of these methods has to be a public async method with call it whatever you want, but it's probably good practice to name it the same as the method that you're calling on the back end. And because we're doing async here, we have to return a task. And in this case, it's a function returning a value. So we're returning a task of type string, because if you remember, our get environment returns our environment string as a return value. And then basically all we need to do is we simply use the call method. This is a method we inherited from our parent class dynamic call provider. And we simply say go call get environment. We don't have to pass any parameters because there are no parameters in this case. Okay, we'll see other examples later. And call method returns something called a tuple. Okay, I was going to try and explain what a tuple is in the context of this session, but I don't have time to do it. It's discussed in the tutorial. Okay, but a tuple essentially, all you need to know is the return value and any out parameters will be baked into that thing. And then we have this thing called argument helper, which helps you extract return values and parameters. So we simply get, in every case, we get a tuple back, and then if we're dealing with outbound data or return values, we extract them just like we did when we were extracting the values on the other side. So argument helper.argument of type string, parameter 0 is the return value from the return result tuple, extracts the value into, in this case, it will be a string variable. Okay, so return token, you can see a hover over there, it's a string because it's argument of string. So that extracts parameter 0, which is the return value, and then we simply return that value. Okay, so similar concept to the dispatchers, just kind of in reverse here. Then what we're going to do is basically add the exact same thing for the other two methods. So I'm going to go grab a method called getLogicalName. Again, the difference now is we have an inbound parameter. We're still returning a string. We still call the method in the same way, but we pass the parameter. And then we're extracting, again, the value of the return value from the tuple as a string into return token and returning it. Okay, and then the third one, again, is similar. Now, if you remember, add two numbers has 3 parameters, 2 inbound and 1 outbound. We're using the return value here to returning it into a function here, returning a decimal value directly. And we've got 2 inbound parameters. What we've done here is declared a parameter which represents the third parameter that's going to come back. And we use call method, calling add 2 numbers, and we pass the 3 parameters. So here's the parameter with the data, the second one that we received through our parameters, and then the one. Now sum is not going to be updated with the return value. The return value still comes back in the tuple. Okay, this simply tells the call method what type of data to expect in that parameter, essentially. And then we're extracting into the sum variable, again, using argument helper. This time the data type is decimal, and we're trying to extract parameter 3 from the tuple. And then we return parameter 3. Okay, so there's our 3 individual methods. And that is basically our service complete. If we do a build on here, just make sure it does. Okay, so we're building our controller, our service. The next step is to create a controller class. So now we're actually going to expose the functionality as a web service by adding a web service controller. And what I'm going to do again is drag in some template code, traditional bridge controller. So this is all of our other controllers. If we look at customers controller, for example, they are OData controllers. Okay, this one that we just added is a controller base. Okay, so this is essentially, if you've ever done ASP.NET MVC development, this is basically an MVC controller. So we're doing things at a sort of manual lower level here. You'll see we've used a route attribute to say the route in the web service that exposes this stuff is /traditional bridge. We've got a commented out authorize parameter where our service is doing authentication. So by putting authorize on here, we protect this class and say you have to present a JSON web token, just like you do for all the OData controllers. You know, they have exactly the same thing. So here's customers controller with its authorized token. So by putting authorize on here, we protect these endpoints and make sure only logged in users can use them. And you'll notice that, again, through dependency injection, here's our constructor, and we're requesting an instance of traditional bridge service. That's the code we just wrote. And we're receiving it through dependency injection, storing it in this local variable. So again, all that remains is for me to add 3 methods that are the endpoints for our service. So here's the first one, get environment. So at /traditional bridge /get environment, we will have the code that simply uses traditional bridge service and calls the get environment method. So what we're doing here is calling into this method that we just wrote, which in turn is calling over the wire to the traditional bridge side, okay, and taking the return value that comes back and baking it into an OK response. If anything goes wrong under the hood, if there's a failure of any kind, Web API will turn it into an appropriate, server error response. We'll do the same thing for our other endpoint. Actually, we might just get finished on time here if we're lucky. Here's our second one. So this one is at a root of traditional bridge /get logical name / and then the value of the logical name, which is then piped into this parameter. And again, we're simply calling into our traditional bridge service, get logical name, and passing the logical name and returning whatever the return value is, the value of the logical name. And our third one, again, is fairly similar. So here's our add 2 numbers endpoint. Again, the root is going to be traditional bridge / add 2 numbers / first number / second number, which get put into those 2 parameters. And again, we're simply calling the service under the hood, passing the numbers, taking the return value and making it the response data. Very simple. So that is our controller complete. Let's just do a build and make sure it does. And now we have one more step. And the final step is we've provided all this code, but Harmony Core doesn't know anything about it. Okay, it doesn't magically learn about it. We have to configure the environment. So we're going to do that with some custom startup code. In the previous webinar, we already created in the services class, we created this startup custom class, because this is where we plugged in and told Harmony Core about our primary key generator. So this is where we plug in custom stuff, okay? And our traditional bridge endpoints are just another example of custom stuff. So I'm going to just put a few blank lines in here, and then we're going to bring in some code. And the code, I'll bring it in first of all, and then talk. Well, I'm going to do it in 2 or 3 sections, but we'll bring it in and talk about it. The first section declares traditional bridge directory. Now, this is the configuration code for running a local process on the same machine. If you're doing remote stuff, then the code will be a little bit different. And again, on the website, you're going to find some information about how to configure remote traditional bridge connections. So the local directory where the traditional bridge directory is going to be found, and a logging level. And we're simply saying if we're in development, then we're going to use the value of xedir. Okay, we're going to tell it exactly where it is, and we're going to use a logging level of 6. If we're in production, then we're going to basically say where is the assembly that contains the startup code, and because the method of publishing a .NET Core application basically puts everything in one place. So we just find the location of the assembly that we're currently in, and that's where the traditional bridge host program will be as well, and log level 2. Now all we're going to do is define the command that we're actually going to run when we need to launch one of these things. So our launch command is going to be path.combine the traditional bridge directory that we just determined up here and the word launch.bat. So that's the batch file we're going to launch to create one of these things. I'm also going to provide it with some environment variables, which is our logging level that we just determined up above as well. Then we simply, well, not simply, but we need to create something called a context pool. So this is a pool of our environment. So it's creating something called an external context pool, and we're telling it the type traditional bridge service. So this is creating a context pool of our service, where the pool can contain instances of the service, and we're also providing all the configuration information. So we're telling it, this is how you launch an instance, and we're telling it the directory, we're telling it the environment variables, and I can't remember what that is. I think that's an initial pool size or a maximum pool size. I honestly forget which. We'd have to refer to the documentation. And the final step, the very final step, is we simply take those things and we register them as services. So we tell our dependency injection environment that we have this traditional bridge service available as a service. So we create an instance of it and add it to a context pool. That is basically how you configure traditional bridge for a local connection, where again it's running. We're running the command, which is essentially the launch.bat, which calls setSDE and runs the program. Okay, and that basically is everything complete. So if we now rebuild this solution, which will take a few seconds, remember we have to use Postman. I'm aware that it is now almost 9 a.m. my time at least, so we're due to finish. We're going to go probably 3 or 4 minutes over. I apologize again for that. I'm going to run up the service, and just like we did last week, oh, it's starting off screen, so let's bring that over here. Just like we saw last week, here's our command prompt, here's our console application that's hosting our Harmony core service, and it's, as we can see, it's running on port 8086 as it was previously. And as we know, we need to take Postman, and we can't access the service until we hit the authorization endpoint. So let's call the authorization endpoint. There's our JSON web token, which we'll copy, and we'll edit the collection that has all of our OData tests in, and we'll update the JSON web token in here. So let's just prove that our service is still running. Let's call read all customers, and there's our customers. So the service is up and running. What we need to do is create a way of interacting with our back-end stuff. What I would normally do is create a separate, in fact, no, let's do it. It doesn't really take that much longer. I'm going to create a new collection. I'm going to say traditional bridge stuff, if I could spell. And I'm going to configure that collection with a couple of things. I'm going to edit. I'm going to say the authorization is bearer token and provide the JSON web token so we can log in. And just like we did in our other environments, I'm going to create a variable called server base URL, and I'm going to set that to https://localhost:8086. In the Harmony core samples, we also have /odata/v1, but this is not an OData controller. Now it could be, we might choose to use an OData controller instead, but right now we've used a web API controller, an MVC controller, so we're not in that /odata/v1 space right now for our Harmony core stuff, our traditional bridge stuff. So now we're going to add a request, and there are basically 3 of them, as we know. We need to use, the request name is get environment, and we'll save that over here, and the URL is going to be server base URI / you can see I've tested this before, traditional bridge get environment. Okay, so in theory we should be able to call this, and there's our response. DBLMS Windows version 11.1.1c. So we got an instance, we called our controller, it got an instance of the service and called the get environment method in the service. It went out over the wire through JSON RPC, spun up a DBR process, called in to the generic dispatcher, got the appropriate dispatcher, it decoded the parameters and called the underlying routines. That called all the way through. And as you can see, that whole thing took 45 milliseconds. If we briefly do the same thing for the other 2 methods, just to show that, let's do add request. This one is going to be get logical name, and basically which is going to do something very similar. So we'll copy that one and we'll paste that in there, and we'll change it to get logical name slash, what should we use, dbl_dir. So let's get the value of dbl_dir from the server, and there's the value of dbl_dir from the server. Remember, we set up a 64-bit environment, so it's program files, not x86. And the final one was our add two numbers. So let's add a request, add two numbers, and we're going to paste in again the URL, which is going to be traditional bridge / add two numbers, and we'll tell it to add 1.1 and 2.2, and we send it, and it comes back with the answer 3.3. So I did warn you ahead of time there was going to be a rapid fire lot of code, and there was. I apologize, we're 4 minutes over, but that's basically implementing traditional bridge the manual way, the long-handed way. Remember, we do also have a whole thing called XF Server Plus migration, where what we do there essentially is we read your method catalog and learn about all of your subroutines and functions, and we generate the traditional bridge dispatcher classes, the main dispatcher class. We code generate the service class on the .NET side, and we code generate the controller class on the .NET side. So we do all of that code that you just saw me write manually. If you've got a method catalog with 500 Synergy routines in there, we will generate all of that code and all of that plumbing, and you can have the thing up and running fairly quickly. At that point, I will break and ask, are there any questions?
There are. So I'm going to go ahead and also, while I'm reading these off, I'm going to go ahead and give people the ability to unmute themselves and ask a question verbally if they'd like. Just also FYI for anyone that needs to jump off now, this, like I said, is being recorded. So if you need to leave and your question hasn't been answered yet, we will answer them all now, and I can follow up with an email afterwards, or you can check out the recording to see what we had to say. So let's start with an easy one first, or I think easy. Are there minimum versions required for Synergy and Visual Studio to do this?
Yeah, for Synergy, Visual Studio, in theory, you can do .NET Core development in Visual Studio 2017. It is not a great experience at this point. Microsoft have totally defocused it. So we would strongly recommend Visual Studio 2019 if you're doing any kind of .NET Core development. That's really where you need to be at this point. And in terms of Synergy, because this is the bulk of Harmony Core is .NET Core, and therefore everything comes from NuGet. So yes, you will be all of the libraries that you're using, and indeed the Synergy runtime that you're using, and the Synergy compiler that you're using, all come from NuGet. So they will be latest versions at all times. So in Harmony Core, basically you're always going to be using the latest version of Synergy, and that does mean you need Synergy 11 licensing available on your machine. Although if you've got Rev 11 licensing, even if you've got version 10 Synergy licenses, as long as you're using Rev 11 licensing, then they will upscale and let you run the appropriate Synergy 11 code. So the important thing is, that you're on Rev 11 licensing. You don't necessarily need to be on SDE version, latest and greatest. But essentially, you're using the latest and greatest version of the compiler because it comes from NuGet in the Synergy build package.
There is a requirement for 10.3.3G on the SDE side for traditional bridge in particular. So anywhere you're deploying it, you need 10.3.3G.
Okay, thanks, Jeff. Good catch. Next, I don't see the questions list, Jacqueline. Is it? Where is it?
Yeah, I'm not sure how I think I can only share them with one person at a time too. I'm sorry about that. Well, hopefully with our new employee on board, Liz, she can help us better use this GoToWebinar platform.
All right. So
yeah, so the next one, this came in at the beginning, and I think I might actually have a good answer for where this person can go, but can you please provide a high-level flow? And I was going to suggest, Steve, and maybe you'll have a better suggestion as the author of this. that if you just look actually in the tutorial, implementing traditional bridge section, there is a high-level flow there for what Steve just did.
Exactly. So this is our documentation, github.com/synergex/harmony-core/wiki, or just click the wiki link. And this is our documentation, basically. So there's a whole bunch of getting started information. This is tutorial 1, just creates the whole thing out of the box. Everything we've seen, literally everything we've seen so far, if you go through tutorial 1, it creates it instantly for you, including all the traditional bridge stuff. In the first webinar, second webinar, we went through this process, which is tutorial 2, which builds up an OData service from scratch, step by step by step.
See what's on your screen right now.
You're not seeing what's on my, oh, thank you, Jeff. Okay, let's do that. There we go. Here's our documentation, everybody. So getting started. This is the tutorial that creates the whole thing out of the box. If you just want to play with it and run it, then you can follow this. It takes 5 minutes. You've got a service up and running, including everything you just seen, traditional bridge. In the two tutorials ago, we went through this process, which creates everything from scratch, literally step by step. In the previous tutorial, we basically followed previous webinar, we followed tutorial 3, which is turning on the authentication stuff. And tutorial 4 is what we've done today. So it's literally step by step by step, adding the project, adding the library code, creating the routines, dispatcher classes, main dispatcher, program, service, controller, configure the environment, run and test. So it literally walks you through the whole flow. This is exactly the flow I followed today. And there will be more. So we're also working on, if you look at the list of tutorials, that's it. That's everything we've got so far. But we do also have some future plans for incorporating custom code on the .NET side, not through traditional bridge, XF Server Plus migration with traditional bridge, doing authentication with an OAuth 2 server, and some examples of calling traditional bridge, both from traditional Synergy programs with the HTTP API and from .NET clients using the web client class. So we've got lots of ideas for future tutorials. And here, there's also a request here, or an opportunity here, that if you want to see something else, then log a documentation issue. This is our GitHub issues list. Feel free to make suggestions about other tutorials that you might want to see, or other information that you need that's not covered here in the documentation. By the way, there's, as well as the tutorials and the basic information, there's this advanced topics section, and there's a whole bunch of more advanced information about all kinds of different subjects. We're pretty complete now. We've been going through the documentation and updating it all and reviewing it all, and we're almost completely complete with that process now. So hopefully you should find everything you're looking for.
Okay, before I read any more of the questions that were typed in, we've got a request for someone to actually ask a question out loud. So Dan Dash, you can unmute yourself.
Okay, can you hear me?
I can. Hey, Dan.
Okay, very good. Hi, Steve. So in the beginning, at the very beginning of the demo, you created the routine dispatcher, and you included a bunch of code in the solution.
Yep.
Why would you include code, and why instead of just say using a library of routines or methods?
Why would I include code? Where are we? Let's make sure we know what code we're talking about here. So in here, you mean? Oh, I'm sorry. Okay. No, you talk. Okay, I get it. Let's stop the service running. You're talking about this library code, right? That we brought in.
Sure. Yes. All that.
Okay. Simply because that code is it's published on GitHub, and it constantly changes, and we constantly improve it, tweak it, improve its performance. Not that it performs badly, but we are constantly working on that. The whole thing, we could ship it as an ELB, but really there's no mechanism to do that. You know, NuGet, everything else in here is shipped through NuGet, and it's .NET, it's packages with .NET assemblies and so on. I guess technically we probably could distribute it through a NuGet package. Jeff, have you got any particular feedback on why we would or would not want to do that?
So there are a couple of advantages to shipping it as a source. One of those advantages is that you can debug it as source. The next advantage is your particular build configuration can matter here. So whether you're 32-bit or 64-bit or some other platform, like if you're VMS, for example, you know, we're not going to ship a VMS ELB image thing, shared image, through NuGet.
Well,
so
we could, but it would be a pain. I mean, that's a good point, Jeff. You know, bear in mind this code could run on any supported Synergy platform. So we'd have to ship DLLs for AIX and Solaris and 32 and 64 and Linux and, you know, VMS and Alpha and VAX and Integrity and Windows. And to be honest, it's a lot easier if you just build it yourself.
Okay, so okay, I see your arguments, but so the important point though is I as a developer should never touch any of this code, because any changes I make are going to be overwritten the next time there's an update.
Yeah, that's pretty much true. I mean, you could, if you really needed to fix something, you know, if you have a problem with something and you wind up working with Jeff, and, you know, it might be that for an instant fix, Jeff can say, go to line 57 in here and change that to a blah, blah, blah. But generally speaking, that statement is true. Yes, you should really not be editing this stuff, just build it. And it doesn't have to be in the same project here. You could hide it away in an ELB and just link against it. It doesn't matter.
Right, okay. And I do have other questions, but I will defer to other people who might want to ask questions and go back.
Go for it. If you've got questions, go for it.
Okay. So you talked about the CodeGen for XF Server Plus does a lot of this stuff for you.
Yes.
Are you thinking about contemplating creating CodeGen for this part of Harmony?
It really already exists. I mean, if you really wanted to, if you really didn't want to sit down and have to write all that code you just saw me write, you could. I mean, obviously you've got to come up with the actual routines that you're exposing. So the methods themselves, obviously, that's the code you're trying to call. So that you've got to write, or it already exists. You could take the approach of defining those routines in a method catalog, even though you may not be using XF Server Plus today. By defining them in a method catalog, you would essentially enable us to generate all the code for you. So I guess a valid use case, if you've got a large number of routines, might be to maintain a method catalog simply for the purpose of allowing us to generate all the dispatchers and services and controllers for you. And that would work just fine.
There's also some thinking here around the new attribute support in traditional Synergy to leverage that into providing basically what the method catalog provides, but just directly in your code without having to jump through any of the XF Server Plus hoops or having to live within the constraints that XF Server Plus offers.
Okay.
Couple more questions. So the examples that you provided were fairly simple sets of arguments, both going to the service and coming back.
Yep.
What if you needed to communicate some complex data to service? Right?
It's there, it all works. It's just it would have been a little bit more to explain. But if you go to, again, let's go back to here. And here, if you go to the documentation, in the tutorial, where is it going to be? It's going to be in, is it in here? No, it's going to be in here, I think. There are examples of...
It should be there twice, Steve, once for the traditional side and once for the .NET side.
I think it is right now, though. But there are examples here. If you're passing structures, for example, what the wrapper code looks like. You'll see here we've got we're calling a method and passing a customer data object. So like with everything else in Harmony Core, just like with the OData side, what you wind up doing is you wind up code generating, in this case, based on your repository structures that define your records that you're passing around. You code generate a data object. That data object can get used on both sides in traditional Synergy and in the .NET code. So here, and we wrap up the data from a record in a data object, and here we've got an endpoint which is receiving a customer data object and passing that along. You'll see we're using argument helper of type customer to extract the data and so on. So it is all fully supported. You can have arrays of things, you can have collections of things with array lists, you can have data objects representing records, collections of records. It's all there, it's all supported. It's just a slightly different syntax in the dispatcher that you write on the traditional Synergy side, and a slightly different syntax on the .NET side in the service. And we've got examples of several scenarios. We probably need more, but we'll work on fleshing that out.
Including, say, like XML incoming data as XML?
That would just be, you would probably just use, depends what you're doing for Synergy. In that case, you would probably be, if it's newer code, you might have a string parameter to deal with that. If it's older code, you might have a memory handle parameter to deal with that. Depends, if you're coming from XF Server Plus, then in that world, people used to use memory handles a lot to represent variable length strings with things like XML. So yeah, no matter what it is, I mean, there's nothing in here that specifically supports or doesn't support XML data. Right. What you're talking about is a variable length string capability, which again, through either a string or a memory handle, you could achieve that.
Well, and then just one final question. The way this is structured, every request is going to start up another separate instance of the traditional bridge host DBR program?
No, it's all managed internally. It's spun up the first time. It's kept around. It's kept in a pool. You might wind up with multiple of them if it's very busy and it needs to. Essentially it's a single-threaded protocol. So if one is busy doing a request right now, it might spin up another one if it needs to. But Harmony Core manages all of that internally and maintains them in a pool. And when it's used, it gets returned to the pool and reused the next time. So no, we're not constantly creating and removing processes.
All right, I was going to ask about licensing, but it sounds like that's addressed by the pooling.
Yes, it is, and again, the licensing aspect is it's a Synergy DBR, so it's going to use a run or an SRun license on the traditional Synergy side, right? And maybe potentially multiple of them depending on how many you need to spin up in the pool. But typically that pool isn't going to grow large. I mean, interacting with it is unless it's a very, very busy service, you might wind up with a handful of them, but I think it's probably rare that you're going to have more than one or two.
Okay, thank you.
Sure. Anybody else?
Yeah, we've got a couple more in the queue. This question came in really early, so I'm sorry that I had skipped you, Tim, but please discuss how traditional bridge is multi-threaded.
In that really the way we just discussed it is not multi-threaded. So while I mean on the .NET side, everything's multi-threaded, of course. But once it spins up an instance of the DBR in the traditional Synergy world, and while it's using that to make a call and respond, that is not multi-threaded. But it's multi-threaded in that if it needs to, it can spin up a second one, a third one, and use them. And from threads on the .NET side, be making calls to multiple synchronous calls to the traditional Synergy backend. So through a pool of processes, multiple of which could be getting used at the same time.
Okay, and then how do we go about debugging our exposed Synergy methods whose code is not within the traditional bridge project using Visual Studio?
if the code is not in the traditional bridge project, you would have, if you want to debug it, well, there's a couple of ways you could do it. Depends what platform it's on. This
is coming from Noreen, by the way. So
okay, right. So Windows. If the code is not, yeah, I mean, you would have to have the code at least available. Jeff, is there in Visual Studio? I mean, generally, the answer to the question is how do you debug it generally? Is you can, as you saw earlier, you can, if you choose, however you launch the process, so whether it's through a command that you send directly or whether it's through a shell script or a command procedure on VMS or a batch file, if you start the process using the Synergy remote debugger and say, listen on this port for a connection, wait for up to 60 seconds for a connection, whatever, then on all platforms you can spin up that process. It will wait, and you can attach to it with the Visual Studio remote debugger. The question of where, but obviously you've got to have the source code available in the Visual Studio environment in order for that to work. Jeff, is there any mechanism in the old debugger world? There was the concept of DBGSRC to point to the source code. Is there any equivalent here, or does the sort of
you don't need one? So you don't need to do any of that. There's two options. Either you have the source file in question open in Visual Studio, and they will auto wire up / guess what the right file is. Or when you step into something, they will ask you, can you please locate the source file? And then you navigate somewhere on your disk and you open it.
Right. So yeah, if you've worked in Visual Studio, you'll be familiar probably with the fact that every now and again, if you debug something that you don't have the source, it pops up a file open dialog and says, go find this file. So as long as you've got access to the source code somewhere, then you can do that.
Thank you. And the last question we have so far, unless anyone else is furiously typing right now, is there any, I'm not going to know how to say this acronym, so PaaS, offering for the Synergex platform now or in the future with these features?
PaaS, platform as a service.
Yeah, I guess that's what that would be.
What you want us to? You're talking about? Not quite sure what you're asking there. Hosting this stuff remotely. I
think they mean a fully managed service that allows you to run traditional Synergy code.
Right.
And the short answer to that is your .NET Core code can happily live in any of the platform as a service things that support ASP.NET Core. So that's primarily Azure. But specifically, traditional Synergy needs to run on a VM that has access to data and configuration and stuff like that. So fortunately, you can run the .NET stuff in your platform as a service environment, and then you just have to have a VM or something that you can run your traditional Synergy code in, and you can connect to that using SSH. And it does all the same stuff. It just has an SSH network protocol in between the .NET Core and the running traditional Synergy.
Right. And that's exactly what our Harmony Core demo environment is, that you're looking at it right now. This service, Harmony Core app.azurewebsites.net, is basically a hosted instance. It's not running the Harmony Core instance is not running in a VM. It's running as an Azure web service, an Azure web, web app, an Azure web app. So we literally deploy to Azure the Harmony Core code. It is connected through, we do have a Windows VM running in the cloud that has a license server on it that this machine is using, and also has an instance of XF server on it, and our data lives on that Windows VM. That could be a Unix VM, So when we hit go get a single customer, that's running in the Azure web app in the cloud, and the data is coming from a Windows VM in Azure with XF Server. What we have not, there is actually a traditional bridge implementation here with our standard 3 routines, but I have not yet configured that, so they will not work right now. What I am going to do when I get a chance is I also have a Linux VM. I could do it on the Windows VM, but I want, just for the sake of it, I want to do it on Linux. I'm going to actually deploy a remote traditional bridge scenario so that this will run these test methods on a Linux virtual machine in the cloud as well, with traditional Synergy on it. I must try and get that done, actually. Any other questions?
Yeah, we had a follow-up from Noreen. She says, I don't get the prompt to open the source. When I add the source code, for example, in traditional bridge /method dir, and add a breakpoint, it is never reached if I send the request via Postman.
The most important thing here is that you've attached to the traditional Synergy side, which is a separate operation. So you're debugging .NET code, that's one sort of debug operation, and then you configure your launch to launch and debug for the traditional side, and that basically blocks and won't allow any requests to be processed until you attach a debugger to it.
Right. Yeah, so the process for other people, the process would be if I wanted to debug this traditional Synergy code from Visual Studio, the process would be I would come in here and say, I want you to run in remote debug mode. That's what this is doing, listening on this port, waiting for 60 seconds. And then when I start this process on the traditional side, once it's running, I would then have to use debug attached to process, and you would select the Synergy telnet-based debugger, and you would tell it the name. So, you know, my system :4444, that's the port that it's listening on, and go connect to the process that way. So you have to specifically go through that, fire it up, then attach to the process in order for the debugging on the back end to work. So it's not going to happen if you're running the Harmony Core app in Visual Studio. It's not going to break in the traditional Synergy backend. Like I say, like Jeff says, you have to attach to the process that way. And it might be, you know, if you're running both in debug and you want to debug both sides, it might be. Can you do it both at the same time, Jeff, or is it best to use a separate instance?
Visual Studio gets a little bit funny with both of them debugging. So it usually works better if you do it in separate instances of Visual Studio.
Yeah, yeah. But that's not just Harmony Core. That's how you remote debug anything with Synergy. You know, you run it up with remote debug. On VMS, obviously the command line is a little bit different, but the concept is the same. You run up the process, and then you come into here and say, you know, you say debug attached to process using the telnet-based debugger, and it's the same process no matter what you're debugging. Any more? Hey, it's great questions today. It's awesome.
I know, so many. We've gone over a half an hour over, which was definitely not our plan, but very engaged attendees. We still have quite a few people out in the audience, so if any of you had a question you wanted to ask verbally, you're still welcome to. If anyone else had anything else they wanted to type in, let us know. We've gotten a couple of messages from people having to head out at various points saying, thanks, great job. So getting some feedback. As the rest of you leave the webinar, there is a really short survey that we'd appreciate you taking. It'll pop up right after you exit. You'll get, again, an email with the recording of the session, so you can have access to it to watch all that rapid fire code again. I think that's it.
The tutorial. You know, everything you saw today is, and there's way more detail in the tutorial pages. So if you really want to get into it, I'd recommend you read through the tutorial as well.
Yeah. Well, looks like that's it.
Great.
Thanks, everyone. We'll see you next time. I'm sure we'll have another one of these that we're advertising soon.
Bye, everyone.
Thanks. Bye.